The habitat is floating at 50 kilometers. Outside, the temperature reads 75 degrees, warmer than a hot summer day, cooler than anything that should kill you. The clouds below look almost peaceful from this altitude. The pressure gauge is nominal. The mission clock shows day 12. Then, panel 7 starts weeping. A seal on the outer composite layer has begun to fail. The fluid collecting at the joint is not water. It is sulfuric acid, drawn from the cloud layer that surrounds the habitat on every side, and it is moving inward. There is no repair crew outside. There cannot be. The corridor has 30 minutes before the contamination reaches the air scrubbers. Venus gives you a place to float. It gives you no way to survive what comes next. The concept reached serious science media coverage because it solves a real problem. At 50 kilometers above Venus's surface, the temperature drops into a range a human body can tolerate. The atmospheric pressure at that altitude sits near one Earth atmosphere, the same pressure your lungs were built for. The gravity beneath you is 90% of what you feel standing in this room. None of that is science fiction. Those numbers are accurate, and the concept earns genuine credibility before. The rest of the physics begins collecting the bill. The problem is that the concept stops there and calls the job done. Everything below 50 kilometers is a different physical environment entirely. The surface of Venus operates at 465 degrees Celsius, above the melting point of lead, above the operating threshold of standard electronics, above the survival ceiling of every structural alloy used in conventional aerospace hardware. The atmospheric pressure at the surface is 92 times what it is on Earth. That is the same pressure as being 900 meters underwater, deep enough that the hull of a conventional research submarine would buckle before reaching it. The Soviet Venera program sent 17 probes to Venus between 1961 and 1984. Every surface lander they built was engineered specifically to survive those conditions, constructed with pressure-hardened titanium shells and insulated electronics, and launched with no crew, no repair tools, and no return hardware. The most successful of them lasted 23 minutes on the surface before heat and pressure ended transmission. Venera 7 landed in December 1970. It was the first spacecraft in history to successfully transmit data from another planet's surface. It survived 23 minutes. The surface temperature at landing was approximately 470 degrees Celsius. The atmospheric pressure was approximately 90 Earth atmospheres. Transmission did not end from a single catastrophic structural failure. It ended from the accumulated continuous assault of an environment the hardware was not designed to survive indefinitely. The data Venera 7 returned before going silent established the surface parameters that every subsequent Venus mission has used. It also established the operational ceiling for unshielded hardware on Venus. Not years, not months, not weeks, minutes. That ceiling is the first wall the floating city concept hits when the math is run honestly. A habitat floating at 50 kilometers requires materials to build and materials to maintain. Structural panels, atmospheric processors, power generation systems, water recycling hardware, food production capacity, medical equipment, communication arrays, and every chemical compound needed to repair and replace all of the above. None of those materials can be sourced from Venus's surface because Venus's surface cannot be accessed by any robotic system that currently exists. The machines that mine, drill, sort, and process raw materials on Earth and on Mars are built from motors with copper windings, electronics with standard semiconductor tolerances, and structural frames made from alloys that begin losing their mechanical properties at temperatures far below 465 degrees. A mining robot rated for Martian conditions would fail within minutes of touching Venus's surface. Building hardware capable of sustained operation at surface conditions is not an engineering upgrade from existing designs. It is a new engineering category that has never been demonstrated at the scale a floating city would require to be self-sufficient. Until that category is demonstrated and operational, every kilogram of material the habitat needs must be manufactured on Earth, loaded onto a rocket, and shipped across interplanetary distance to a floating platform in a cloud layer made of sulfuric acid. That supply chain is not a logistical inconvenience. It is a permanent, non-negotiable life support dependency with no local fallback. The moment the resupply schedule breaks down, a launch failure, a funding gap, a political decision, the habitat begins consuming its reserves and cannot replenish them. There is no equivalent of living near a river or a forest. There is no local material that can be harvested and used. The habitat either receives continuous deliveries from Earth or it degrades toward failure at a rate set by how fast the acid outside is eating the structure. That rate is not slow. Sulfuric acid at the concentration present in Venus's cloud layer does not corrode surfaces the way iron rusts in wet air, gradually, seasonally, in visible patches that spread over years. It attacks every exposed surface continuously at a rate that increases with temperature and acid concentration. The composite materials proposed for Venus habitat construction are more chemically resistant than standard aerospace alloys, but chemical resistance is not chemical immunity. Every outer surface of the habitat begins degrading from the moment it enters the cloud layer. The most vulnerable point in any habitat structure is always the interface between two different materials, the seals, gaskets, joints, and penetrations where one component meets another. Those interfaces are where the acid finds the path of least resistance. A seal that performs correctly for 6 months does not carry a guarantee to month 7. The degradation is cumulative and irreversible, and it proceeds whether the habitat is occupied or not. A single compromised seal is not a repair event, it is a mission-ending sequence. Not because the habitat floods instantly, because there's no way to repair it from outside. A crew member in a standard pressure suit cannot survive in Venus's cloud layer long enough to reach the failure site, assess it, and fix it. An acid-resistant EVA suit with the chemical tolerance and thermal protection required for Venus cloud operations does not exist in any demonstrated operational form. Even a fully functional acid-resistant suit would require the repair to happen while the habitat's internal atmosphere is being actively managed, while the contamination is spreading, and while every other seal on the outer hull is undergoing the same continuous degradation process. Fixing Panel 7 only establishes which seal failed first. It does not address the 17 other seals that have been accumulating damage since launch day. It only changes the order. The obvious engineering response is better materials, denser composites, ceramic coatings, acid-resistant polymers layered over every joint. That direction is real as a research program. It fails as a mission architecture for a reason that better materials cannot address: mass. Every upgrade in chemical resistance adds mass to the habitat structure. Every additional layer of protection is a kilogram that must be launched from Earth. The tonnage required to construct a fully sealed, acid-resistant floating city of any meaningful scale, using materials exotic enough to survive continuous cloud layer exposure, has never been calculated to produce a number that any space agency budget has ever been near. For reference, the International Space Station cost approximately $150 billion to assemble and has required continuous resupply missions for over 2 decades to keep 6 people alive in low Earth orbit, where the environment outside the hull is inert vacuum. Rescue takes hours, and the distance from Earth is measured in hundreds of kilometers, not tens of millions. Venus is not low Earth orbit. The resupply window is months. The environment outside the hull is chemically active. 6 people cannot maintain a Venus colony, and there is no rescue window because rescue requires a vehicle that can reach the habitat, and a vehicle capable of doing that must survive the same cloud layer that is currently dissolving the habitat's outer skin. That last word, rescue, connects to the problem the concept almost never addresses directly. Venus's surface gravity is 90% of Earth's. From a physiological standpoint, that is one of the most attractive features of the entire concept. The human body does not waste away in low gravity the way it does in the Martian environment. From a propulsion standpoint, it is a trap. Launching off Venus requires nearly as much propellant as launching off Earth. A return vehicle that departs from the floating habitat must accelerate to orbital velocity against a gravity well almost identical to the one it left at launch. Every kilogram of return propellant is a kilogram that was launched from Earth, shipped to Venus, stored on the habitat while the acid worked on the hull, and then ignited for a departure burn that still has to successfully reach Venus orbit before the trans-Earth injection can even begin. A mission profile that sends a crew to a floating Venus habitat and then brings them home is not substantially cheaper in propellant terms than a mission that sends a crew to low Earth orbit and then continues on to another destination entirely. The colony is not a waypoint. It is a gravity trap with a sealed roof. The comparison to Mars is not a minor footnote. It is the clearest statement of what the Venus concept actually costs. Mars has a thin atmosphere, cold temperatures, and a surface that kills an unprotected human. It also has a surface that can be reached by rovers built with existing hardware. Rovers operate there, drills operate there. Electronics and motors function in Martian temperatures without exotic engineering. The surface pressure is low enough that a suit breach gives the crew time to respond, and Mars can be left. The launch energy required to reach Mars orbit from the surface is a fraction of what Venus demands. A crew in trouble on Mars has an escape vector that is physically achievable with hardware that could be designed and built. A crew in a deteriorating Venus habitat does not have that vector because the vehicle that would provide it must first survive the same environment that is causing the deterioration. The concept's advocates sometimes respond that future technology will close these gaps. Better materials, better robots, better propulsion. That is true as a statement about the future in general. It is not a Venus colony plan. A plan that depends on engineering that does not exist is a list of requirements for other engineers to solve before the plan can begin. The floating Venus city, as currently described in science media and proposed in research papers, is a thought experiment about what Venus would need to become before it could be useful. It is not a description of what Venus is. What Venus is, specifically, is the most hostile major body in the solar system for sustained human presence, not because of any single parameter, but because of the combination, a surface that destroys hardware in minutes, an atmosphere that corrodes everything that enters it, a gravity well that charges full price for departure, and no local resources to offset any of the above. The temperature at 50 kilometers is survivable. That is true, and it will remain true. It is also the only thing on that list that does not actively work against the mission. SpaceX's current Starship architecture is designed around Mars surface operations, propellant production from local resources, reusable vehicles, launch windows that allow crew rotation and resupply at manageable cost. None of those assumptions transfer to Venus. Local propellant production requires surface access that does not exist. Reusable vehicles must survive the cloud layer to return. Launch windows exist, but operate against a gravity penalty that Starship's Mars economics were never designed to absorb. The mission that Starship is being built to run on Mars cannot be run on Venus with the same hardware or the same cost model. The floating habitat at 50 kilometers will eventually ask the question that the concept never cleanly answers. What happens when the structure has degraded past the point where resupply can keep it functional, and the crew needs to leave, and the return vehicle's propellant budget was calculated at Earth departure prices 6 months ago? The temperature outside is still survivable. The acid has been working on the hull since day one. The nearest replacement seal is in a cargo hold that has not launched yet. Venus does not offer a second Earth. It offers a sealed container above a surface no one can reach in an atmosphere that dissolves the container, held in place by a gravity well that charges full price to leave. The temperature at 50 kilometers is the one number that works. Everything else is the bill.